Hello and welcome to another video tutorial for the next generation vectorizer ContourTrace. In this video, we are going to learn how to create a camera calibration file. We will learn about radial and tangential distortions and how camera calibration can minimize them. So, let's jump in and get started by answering what is radial distortion. Radial distortion is recognized when straight lines appear curved on an image. While all lens types produce some amount of radial distortion, images from a fisheye lens have the most significant distortion. Next, tangential distortion occurs when the camera lens is not aligned perfectly parallel to the camera's imaging sensor. This causes images to be projected as skewed in one direction. Both distortions are due to the camera's internal inaccuracies, and they affect the imaging of the objects, and thus adds inaccuracies to contour extraction. With the help of the camera calibration process, we can eliminate or greatly reduce both internal inaccuracies. The calibration process generates an XML file. We will refer to it as the camera calibration file. This file will allow ContourTrace to correct the camera's internal distortions when provided to the calibration operator. Now, let us see how we can generate the camera calibration file. The calibration module generates a calibration file from the images of a chessboard pattern captured by the camera. Therefore, we will need to print a chessboard pattern. Instructions on how to print can be found in the description below. Next, we need to set our camera settings. Because the camera calibration file is unique for every camera setting, we must use the same lens, focal length, and aperture size while capturing the calibration image. The same setting must also be used while capturing objects to be imaged. If you use the camera of your smartphone, calibration is not useful because smartphone cameras perform their own correction. When the print is ready and the camera setting is fixed, take at least 10 images. While capturing, move, rotate, or tilt the chessboard pattern, or change the distance to the lens. But keep the whole chessboard pattern visible in the frame. Now, when the images are ready, camera calibration can be performed in ContourTrace. Open the camera calibration module. Add the images. And click Create Calibration File. Provide the destination path and file name for the generated camera calibration file. We are going to save it on the desktop. Here is the generated camera calibration file. We can now provide this file to the calibration operator. Then open an image to see the correction applied. Add the calibration file. By toggling the calibration option, we can see how significant the distortion is on this image. Let us load an image of a tool to check the distortion. With this overlay, we can see the distortion correction on the edge of the image. Let us quickly extract contours from this image. That is all for this video. If you want to read more about camera calibration, there will be a link to the documentation page in the description below. Thank you for watching, and see you in the next video.